Hello students, good afternoon all. So in this lecture, in this session, we are going to study about the binary sign multiplication. Okay, so binary sign multiplication uh, is little bit complex because sign multiplication, sign division need something simple methods to solve it. Otherwise, it would create more incorrect or wrong results. Okay, so we are going to use one algorithm that is named as Booth's algorithm, and this Booth's algorithm was specifically proposed for the sign binary multiplication only. Okay, and this algorithm can be used for sign and unsigned binary multiplication for both, but mainly it has been proposed and it was producing more accurate result with simple steps for sign multiplication. Okay, so we will see with an example how to use this Booth's algorithm to solve any sign multiplication. Okay, so we are going to see binary sign multiplication using Booth's algorithm. Okay, we will take one example, that is 7 into minus 3. This should produce the output as minus 21. Okay, now this is one example. So first step is to initialize. As per this algorithm, check after start, how to start with this algorithm, that you have to check, you have to initialize your accumulator value, q minus 1 value, and q and count. Okay, so A is your accumulator value, which will be initialized to 0 first. Q minus 1 is 1 bit, which is initialized to 0. M will store your multiplicand. So 7 is multiplicand in this example and 3 is multiplier. So M will store 7. In binary, we represent 7 as 0, 1, 1, 1. Q will store multiplicand. So multiplicand is minus 3. So 3 is represented in binary as 0, 0, 1, 1. How to write minus 3? Minus 3, to get any minus number or sign value, we use 2's complement method, right? So plus 3 is represented as 0, 0, 1, 1. Minus 3 will be represented with the help of, first you have to take 1's complement of this number by inverting each bit. Okay. Then you have to write 2's complement of this by adding 1 to 1's complement. So 0 plus 1 will be 1, 0, 1, 1. So this will be 2's complement and this will be representation of minus 3. Okay. So Q will be equal to minus 3. This is minus 3. This is plus 3 and this is minus 3. Okay. After this, count n. Now what is count n? Count n is equal to 4, means it is the number of bits required to represent m and to represent q. So 4 bits are sufficient to represent your multiplicand and multiplier. So your count n will be 4. Okay. Now at the same time, we are going to also write minus m because we are going to use minus m for the addition purpose in algorithm. Okay, so we will first see how to write the minus m also. So plus m is 0, 1, 1, 1. To get minus m, first we will take its 1's complement by inverting each bit, then add 1 to it, 1, 0, 0, 1. This will be 2's complement and this will be your minus m. Okay. So this is about the initialization, the initial steps to be written. Okay. Now we will see how to solve example using this algorithm, how to proceed further. So this is the first step. of initialization. Okay. I will just drop this down so that we will use this our example. Okay. Just a minute. So we will use this for reference. We'll keep it over here. Okay. So I can write here what we are going to use is A, Q, Q minus 1. Okay. This 3. So we will, I know what A is. A is initialized first to 0. What is my Q? Q is minus 3. So what is minus 3? Minus 3 is 1101, right? So 1101 is your minus 3, which is 2's complement of plus 3. And minus Q minus 1 is initialized to 0. So this is your first step, that is initialization. Okay. So A is 0, Q minus 1 is 0, M is plus 7, that is 0, 1, 1, 1. And minus M is, what is minus M? Minus M is 1, 0, 0, 1. So minus M is 1, 0, 0, 1. Q is 1, 1, 0, 1. So this is your initialization. Okay. Okay. Now, this is your first step. Now, after initialization, you will check Q0 and Q minus 1 bit. Okay. So Q0 and Q minus 1 bit, whatever is the value of Q0 and Q minus 1, according to that value, you are going to perform these 3 different operations: A minus M, A plus M, and arithmetic right shift. Okay. So we will observe this bit. This bit is Q0, this is Q1, Q2, and Q3. So this will be Q0 bit and this is Q minus 1 bit. So Q0, Q minus 1, if it is 1, 0, I will perform this operation, that is accumulator will store with a value A minus M. So how to perform this step now? A minus M means I will add minus M into A. So what is my minus M? 1001. So I will add that value into A to get new value. Okay, 0 plus 1, 1, 0, 0, 1. And all other values will remain as it is. Okay, so this will be first step, that is my accumulator will store a value A minus M. So after this, see, after A minus M, you have to perform arithmetic shift right operation for A, Q, and Q minus 1. Okay, so while performing right shift operation, your first leftmost bit is retained as it is. Okay, so retain this value as it is and shift each bit by right. So this will be 1, 0, 0. This one will get shifted over here. 1 is shift करना है right की तरफ. So this will be 1, 1, 0, and this one will get shifted over here. So this is right shift. Okay. So after right shift, reduce your count. Now here in the initial stage, my count was 4, right? Count was 4. In this step, after right shift, now my count will be reduced by 1. It will be 3. And this will be called as cycle 1. Okay. Now second cycle. So after reducing your count, you have to check, is my count equal to 0? No. If it is not equal to 0, you have to repeat these steps again. So again, you have to check Q0 bit and Q minus 1 bit. Now this bit is 0, 1. So if it is 0, 1, you have to perform A plus M. Okay. So A plus M means whatever is my A value, I'm going to add into it my M value, that is 0, 1, 1, 1. Okay. So 0 plus 1 is 1, 1, 1 plus 1 is 0, carry 1, 1 plus 1 is 0, carry. So after 4 bits, whatever bit you will get, that will be discarded. So fifth bit will get discarded. And Q and Q minus 1 will remain same. Okay. So this will be A plus M. So after A plus M, again arithmetic right shift. So during right shift, first bit will be retained as it is and shift towards right. Okay. So all bit will be 1. This 0 will get shifted over here. So this is your right shift for A, Q and Q minus 1. After right shift, reduce your N by 1 and this will be your second cycle. Okay. Now, third cycle. Again, n is 2. It is not equal to 0. So again, I will repeat the same step. So I will again check my Q0 bit and Q minus 1 bit. Okay. So I will check. So Q0 bit and Q minus 1 bit is now 1, 0. So if it is 1, 0, again, I need to perform A minus M. Okay. To perform A minus M, I will add minus M into A. So what is my minus M? My minus M is 1001. Okay. So I will add 1001 into A. This will be 1 plus 1 0. Carry 1 1 0 1. Okay. And Q and Q minus 1 will be written as it is. So this is A minus M. After A minus M, again perform arithmetic right operation. Okay, right shift operation. So while right shift operation, retain this bit as it is and shift towards right. Okay, so this will be 0, 1, 1, 1. This one will get shifted over here. This is right shift. After right shift, to reduce your n value by 1, this will be your cycle 3. Okay. Now again n is equal to 1 means it is not equal to 0. So if not equal to 0, repeat the same step. Again check Q0 and Q minus 1 bit. If it is 1, 1 C. If Q0, Q minus 1 is 1, 1, directly perform the shift right operation. Okay. So while shifting right, retain first bit as it is and shift towards right. 1, 0, 1, 1, and this will be 1 here. Shift right operation. After shift right operation, reduce your n by 1. This will be your fourth cycle, and your result is there. So your final result will be stored in A and Q. Okay. Now your final result in this case, it is you got result as 1, 1, 1, 0, 1, 0, 1, 1. So this result is in 2's complement form. Okay. To check your actual result, what I am expecting my result should be minus 21. So it is negative result as my result is in 2's complement form. But whether it is 21 or anything else that I need to check, and to check my result, I need to take 2's complement of the result. Okay. So 2's complement of this obtained result will be first take 1's complement and then add 1 to it. So this will be your final result, and this is binary representation of 21. So 7 into minus 3 minus 21, and I got this result by using this Booth's algorithm. So it's very simple. Just you have to follow this flow chart step by step. You just have to keep checking your Q0 and Q minus 1 bit. And while performing addition or subtraction, before right shift operation, you have to take care that your accumulator value, that is most significant bit, is written as it is, and you are shifting 1 bit towards right. Okay. So in this way, you can solve any binary signed or unsigned multiplication using Booth's algorithm. So try to solve more examples to understand and to recall this Booth's algorithm. Thank you.